Hello, everyone, and welcome to the AEC's podcast, Shapemakers. Before we dive into this week's episode, make sure that you're signed up for the Aluminum Extrusion's Technical Seminar and Exposition, also known as ET, April 30th through May 2nd, 2024, at the Rosen Shingle Creek in Orlando, Florida. Make your travel plans now. Join the aluminum extrusion industry's professionals from over 50 countries. Do not hesitate any longer. Grab your tickets at ET'24.us. And now to our episode of Shapemakers.
Hello, everyone. This is Jason Weber from the AEC. I'm joined today by Lorenzo Donati from the University of Bologna. Lorenzo and his counterparts from the university will be presenting the process analysis and optimization in conjunction event that'll be at ET on Monday, April 29th. This podcast is in a series of, sorry.
Correct. Hello, everybody.
Sorry.
Sorry, I will not interrupt you.
No, that's okay. So joining us today is Bruno Donati from the University of Bologna.
Lorenzo Donati, not Bruno.
Oh, there's a Bruno from Prezesi.
Yes.
Yeah.
If you like, I can also change my name, but that's
yeah. All right. Take 3. Hello, everyone. This is Jason Weber from the AEC, joined today by Lorenzo Donati of the University of Bologna. Lorenzo and his counterparts from the university will be presenting the process analysis and optimization clinic, which will take place on Monday, April 29th as part of ET. Hi, Bruno. Hi, Lorenzo. How are you today?
Hi, Jason. It's a pleasure for me to be here today. Thank you for inviting me.
Oh, we're thankful to have you and appreciate you taking, part of your evening over there in Rome to be with us today. I'd like to start with maybe you could give us a little bit of history on the process analysis and optimization program that you have created and what you'll be presenting at ET.
Yes, the workshop we are going to repeat at this ET conference edition started in 2012 in Miami. We were asked for the first time to teach to the ET attendees at that time a kind of course that is able to link together the theory of extrusion to the everyday problem and the practice of the extrusion plant through a specific instrument. We develop since 2001, because we started working in aluminum extrusion in 2001, we approach the aluminum extrusion process through FEM simulation, and we developed a lot of competence in this field. FEM simulation is a powerful instrument to understand and to analyze the extrusion process, but it's also a powerful instrument to teach about what happened inside that complex machine that is an extrusion press. And it's not so easy to look inside of the press, what is going on in the billet, what is going on in the dies and in the tools in order to produce a profile. Instead, FEM simulation, if properly set, can allow us to visualize what happened inside and to understand, to foresee also what could be done in order to improve the process, to understand the link between defects on the profile, the problems during the process, and all the other parameters we have in the process. So the key idea of this workshop is to use FEM simulation as a tool to visualize, to analyze what's the basic mechanism we have in aluminum extrusion. That's why the course is divided in some sections. we start with a first lecture about the basics of aluminum extrusion in terms of more of aluminum extrusion of metal forming, because we need some theoretical background in terms of what is a strain, what's the difference between an engineering strain and a true strain, what is a stress, but also what is a flow stress in the material. We have to know what's a strain rate and what's the effect of the strain rate, but we have not to be worried because we try to keep the approach open to an industrial audience. So it's not required a big background in the theory, because we will be able to provide in this first part of the course all the basic knowledge in a simply but at the same time complete way in order to better understand the subsequent part. The second module of the course is an overview of the material flow. That sounds pretty easy because everybody knows, everybody at the T knows that we have a billet that flows inside the die and then in a profile. But how it happens in a situation with a high friction we have in the extrusion process, it's not so easy to be visualized and create some effects that pretty often surprise also people with a lot of experience. And again, the simulation is quite useful in order to visualize this effect, to understand, for example, concept like the billet skin, what's the charge weld, extension of the charge weld, part to be discarded in the profile. After the module on the material flow, we will move to two different types of welds we have in extrusion: the charge weld in the billet-to-billet extrusion, how it's formed, how we can optimize, how we can reduce the extent of the charge weld in order to improve the process productivity. Then we will move to seam welds, so the quality of the welds inside an hollow profile, and what could be the basic rule of thumbs, practical, in order to improve the die design for improving the quality of the welds, but at the same time, again, to use FEM simulation and check what could be the best welding criteria in order to foresee the quality of the seam welds if we need to produce a profile for a challenging application like severely deforming the profile after extrusion in order to obtain a shape that is quite different than the first part. Another module is on the tools, so dies and tools, to understand what is the loading condition on the tools and the die life, effects of fatigue, effect of temperature, so also the creep effect and the mixture of these two phenomena on the die that expire really, let me say, a really ugly life. All the tools are in quite a severe condition. The last module is on microstructure. We'll not be able to go so many in details on the microstructure, but we will run the overview of the microstructure of aluminum alloy during aluminum extrusion, focusing on some challenging aspects that today are microstructure evolution. It's a lot of content. The time, it's not so much, because if I properly remember, we will start at 8:30 in the morning up to 5:30 in the afternoon. And all the feedbacks we got from the past edition is it's an incredible amount of information, and we will need weeks in order to digest all the information we collect by this workshop. So I hope that all the feedbacks also of this edition of the seminar will be as much positive as at the past.
Yeah. So as part of ET Week, this is one of 6 in conjunction events or classes that are being held. One of the other classes is the Extrusion Excellence course. So I'm wondering, can you take us through the differences in what somebody might learn in the extrusion excellence course versus your process analysis and optimization?
So let me say that my choice would be, my suggestion would be to attend both, because both are able to provide a lot of useful information. I speak also for the course of Wojtek, because it's a friend, and he has a great experience on aluminum extrusion. So I perfectly knows that all the people that attended his courses got a lot of important and relevant information. The main difference between our course, I suppose, let me say, or I know, but unluckily I was never able to attend his course because it's always in conjunction with us. So I really would to follow once at least the course of Wojtek, but I didn't yet. Again, I think that the main difference is the FEM simulation. We focus our course on don't let me say teaching FEM simulation, but using FEM simulation to visualize, to understand effects. Of course, I'm pretty sure that also Wojtek does some of this activity, but our course, it's really focused on that. All the aspects we will teach from a theory and a practical point of view are linked together through FEM simulation in order to, let me say also, let the audience understand how much powerful is this instrument that can really be can be used like an instrument for teaching and for better understanding the process. So I think that simulation is the key point of our course.
So one thing I guess I maybe should clarify. So as far as the process optimization course that will be held on Monday, there is also an extrusion excellence course that will be held on Monday, but the extrusion excellence course is actually done twice. So there will be another class on extrusion excellence which will be held on Friday. So I guess if I'm hearing it and kind of knitting this all together, go to the process optimization on Monday, and then hit the extrusion excellence course on Friday.
Absolutely, my suggestion too.
Oh, good. So, theoretical, practical, it all starts to, come together. So you mentioned that at ET'12, which was in Miami, was the first time that this course was actually presented. You yourself have been working, around the extrusion industry since 2000, 2001. And, since 2012, there have been, probably, over 100 to 200 people that have actually attended the process optimization workshops that have been, part of ET now. I'm wondering how, in your view, how has this course itself changed over time? I'm sure you're constantly, updating, you're finding new, new analytical tools and developing new theories. So how has this course evolved over time?
Yes and not. I want to be quite honest with the audience. I mean, when we started the course in 2012, we summarize the knowledge we, as a research group of the University of Bologna, collected in the 10, 12 years before. But we also did a deeply review of a lot of quite relevant articles from the literature, most of them from previous ET seminars. So ET seminars, the book, the proceedings of the ET seminars are in front of me in this moment in my office, and are always a reference point for the state of the art of aluminum extrusion. And they are also the reference for the workshop we will provide few weeks. In the first two editions, we start evolving a little bit the material, mainly in order to adjust the topics on the remarks and the feedbacks we got from the audience. Some part were told us to be a little bit maybe too theoretical and not so many practical. Other part were not so clear maybe. So we adjust. We included more example. We added more data we collected in industrial trials and so on. But let me say that in the last 2-3 edition, course is kind of stable. It's quite difficult to add new material because the course is really still today very, very intense. So we would like to add new material, but there is no time. The course, one of the negative feedback is a kind of rush, because there are really a lot of information to be transferred in the 8 hours, the 8-9 hours that with the breaks are 7 hours and a half and something like that. And it's difficult to add new concept and new material. We are thinking also to split the course into parts, a basic one and advanced one, in order to include more and more information. But for the moment, we are in a kind of status. So I would say that if you followed the course in 2 years ago, in 2022, it will be pretty similar to this edition. Teachers are almost the same. In Orlando in 2012 were Barbara and me, and for this edition also Luca Tomesani will join us again. He will be able to attend the conference, so we will be 3 teachers. Each of us will teach 2 modules, and every me and all the other one will provide the most updated details we can do on the single topics, but the main structure, the slides and the material is almost the same of 2022. So I would like to be do not create too many expectations on this point.
Yeah. No, and that's great. I mean, thank you for clarifying that. I think there is one thing that you said, which is the ET proceedings that you said you have right on your desk, which, you know, each registered attendee for ET, not the in conjunction events, but for ET, will receive a copy or receives a copy of those proceedings, because obviously, you know, the fundamental part of ET is the technical program that we're putting together, that is coming together extremely well, considering the last TT was only 2 years ago. There are going to be around 140 technical presentations in 7 different tracks, you know, billet process, dies, extrusion equipment, sustainability and management issues, as well as new this year within ET is a new track, which is extrusion innovation, which there are several papers that have been written on, you know, end uses for aluminum extrusion. So it's really going to be quite a week, not only with these in conjunction events, obviously with the main ET conference that will happen. There's really, if you're involved in the extrusion industry, whether you're a manufacturer, a supplier to the extrusion industry, or an end customer of an extruder, there is something there to take away. And you know, the best part of it seems to be the proceedings, and that book, or that is
they absolutely are the best. I remember when I was a student, slightly before starting my my master thesis, at the end of my student track, I asked Professor Tomesani if I could do the thesis on aluminum extrusion, because my father was related to the aluminum industry in the window frame market. And he told me, yes, I have something for you. And he brought to me the proceedings of 4 edition of the T. I think the preliminary one, and I spent like I think 2 months reading all of them to understand all lot of the process. But the first time I read them, I got, I think, 2% of the content. Then after some years, I read it again, and probably I got the 15%. Still today, I look at them and I still get information from past papers, not only from the most recent one. Sometimes I find really interesting information from edition of 88 or 92 and so on. And it's so nice to have them. I like the paper, so I have them printed, and it's so nice for me, open them, look at them, and I remember that paper, it's in that volume, and it's around in the middle, and I am able to get that picture that I needed, and I was thinking about, and I want to transfer to my students. So amazing opportunity to have them.
Well, that's a great commercial. Or what you're going to get at
okay,
ET.
we can delete it.
Yeah, I mean, I've been involved with ET since 2016. Was really my first. I sit on the ET planning committee. I actually help and run one of the tracks. But I think the most amazing thing to me of being involved in the production of ET is how much care and how much scrutiny goes into every single paper. Because when we kicked off for ET'24, 2 years ago, basically, and opened up the call for abstracts, we probably had over 250 abstracts that were submitted. Of course, not all of those abstracts make it through to the final paper. But out of those 250 abstracts that were submitted, 100, I believe it was 180 papers were actually submitted that went through a review process. And out of those 180 papers, we have about 140 actual presentations that will be made in all these different tracks. But then there are also some papers that will not be presented, but they will be published only. So while it is absolutely imperative to go to ET, to learn, there are also things in those proceedings that won't necessarily be there. So you kind of get, you still get everything, but what's left over is, I would say, the cream of the crop, so to speak, of everything that's been submitted from the beginning since we started planning for this ET. So it is absolutely imperative that this event is a technical event, and the people that go there to learn. And then this is why we have the in conjunction events that come along with it, where allows the attendee to delve down deeper into the process and really get that absolute fundamental understanding of what is happening with extrusions. Because as we all know, end use of extrusions, whether it be in automotive, building and construction applications, right? The designers and end users that are demanding extrusions, they need better, they need more complex, they need different alloys. And it's through ET and the in conjunction events where that understanding of the entire universe of aluminum extrusions begins to, can't say totally understood, as you mentioned, you're still learning, but that fundamental understanding is absolutely imperative to a successful extrusion business and utilization of extrusions.
Learning never ends, so it's a continued process, and we will learn till our last day on this earth. So, but on this point, you remind me something about an information that could be of interest. Who attended our course in the past? Let me say that 50% of attendees in the past were directed from aluminum industry. So people involved in the press or involved in the die design or, in the profile design and so on. But the remaining 50%, they were equally shared among final users, because sometimes the users of the profiles needs to know some technical details about production that could be useful in order to design the profile at its best. Another equal share are die maker. Die maker has a great knowledge about how to design a die and how to perform a quite effective die, but sometimes they do not have an overview of the whole extrusion process. Maybe sometimes some die designer people that is in the design room never saw a press, never saw how it works, or how much challenging is to obtain a profile. And another equal share is people that is curious to deepen their knowledge because they are consultant or are expert, but they would like to have another point of view of the process. We got a lot of attendees that was embarrassing for me to have in the room, because they were people that wrote papers that I read in my thesis. So people with a lot of experience that were sitting in front of me, asking me, that were speaking about the process. And I asked, why you decided to attend the course? Because every time, if also I know a lot about extrusion process, looking what's the point of view of someone else that is able to analyze the process from another point of view, or for example, from FEM simulation that I'm not an expert into, can wider one more my point of view, my information about the process, and find different solution to problems that still today were approached in just one single way, when probably there could be also other possible way. So that was quite nice, and we were really happy about these feedbacks. Also from people that says, okay, I know some of the part of the course, but having a course that starts from the beginning up to the end with a kind of line that connects several aspects is a quite important overview to resemble the whole mosaic, the whole scheme of the process.
Yeah, that's a great point. I didn't think about, just the aspects of even like a die maker, basically a supplier into the extrusion industry, and what they might learn, from a course like this. To kind of dovetail into, what you just said, one of the changes that has been made to the kind of the format of ET this year is a more let me say an understanding for the end users. So all of those, as much as possible, those 140 technical papers that have been or will be presented, we've actually categorized them, along an end use. So say somebody in the automotive industry, and okay, here are all the papers that could have relevance to the automotive market, or building and construction, right? You can think of the big pillars within extrusion uses, and we've categorized those papers along those lines as well. So not only do you have kind of the typical ET paper categorization around, process and what what part of the process you're interested in, whether it be quench or maybe handling systems or dyes, something like that. But then this end user part, because I think the whole view of it is that, an informed end user of extrusions will make a better customer, right? Because we can all come together, as supplier and customer and work, to develop these next generations of extrusion applications that are coming along. So it's very, I like your analogy, drawing that line, connecting the dots. I think that's primarily what ET does, is we're connecting the dots between all these different things. So that's important. What about after ET? You get contacted by people within the extrusion industry that are, looking for help? Is there, are there let's say services that the university offers, directly to?
Yes, absolutely.
Yeah.
We do a lot of projects together with company that could be both government funded or also directly funded by companies on the several aspects of the extrusion process. In the past, we work in the quality of the seam welds, for example. We worked in the field of minimization of charge weld extension, and many of the results of this project we did in the company are now in the workshop after authorization, of course, of the company we did the work with. And also today, we are running some European projects in cooperation with industries in the field of aluminum extrusion for automotive, but also in the field of microstructure prediction, again for automotive, but also for train transportation, for other application in which the control of the microstructure it's very challenging. So we did a lot of activity tailored to the company. Also, the workshop itself we did in the companies as training for the technicians. We did in the past in some extruders, but also in some die makers company, in order to broaden the view and provide a more accurate knowledge on the process. What we suggest is that the course itself is a so huge amount of information that to be digested, they need time. And if somebody attended the course itself and then come back to the company, to its work, to everyday work, it's, let me say, not so useful. Instead, if part of the course are applied day by day by trying to optimize single part or single aspects of the process, also in cooperation with the university or with other research center, that's the most useful way in order to digest the content and make the theory practical rules and practical application of the concepts.
Okay. Well, why don't we'll kind of wrap it up. I'll make a statement on, let's call it networking, and then, ask you about, right, follow up, obviously you give your contact information, what other types of projects do you work on, both, like you said, government funded as well as privately funded, with extruders, and I think that would be good.
Okay.
Okay. Well, Lorenzo, I wanted to thank you for taking the time, to join us today, not only to promote, the In Conjunction events. We went through ET and the value there, but I would kind of also like to take this opportunity to remind everybody of the great opportunity there is within ET in that week to network, to learn as you mentioned, and just to come together as an industry and figure out how we move it, move it forward into, the next generation of aluminum profile. So with that, Lorenzo, why don't you just take everybody through maybe your daily life when you're not at ET, for the University of Bologna, and some of the projects or some of the things that you do when you're not speaking at ET.
Absolutely, yes. First of all, I would like to confirm you that also for us, it's quite important, the ET, for networking. We met them colleagues, but let me say, first of all, some very often friends. Let me say that it's really a pleasure to come to ET because it's a kind of family, a big family of people that works in the same field and share experience, knowledge, and so on. So it's a pleasure to meet these friends at ET every 4 years in the past, now 2 years, and then we will see. So networking is always a great opportunity for everybody. And also for us, it's an opportunity also to meet person which we are working with or we worked in the past, because we have the students at the university, we teach to the students, but that's, let me say, like 15% of our time. The other part of the time is research, and our research field is aluminum extrusion, and we do research in several ways. Some of them can be basic research that is funded by institution like university itself or specific project. But most of our projects are today applied projects directly with company, with extruders, with the makers, with final users of the profile. And this project can be both funded by government like EU, European Union, or Italy government, but also country like Germany or France through their own funding, in order to analyze specific process, specific problem of a customer, in order to try to find solution or instruments to find the best way to gain solution to the problems. So the project we are running at the moment are, for example, related to a circular economy, how to optimize at its best recycled alloys in order to have, by recycled alloys, mechanical properties that are comparable or even the same or possibly better respect to the primary one, in order to close the green loop of the production, because the resources of the planet are not infinite, and so we have to do our best in order to keep it clean and green and leave a planet to our sons and daughters. So that's, from my point of view, quite important aspect of the engineering. Other aspects are, for example, the microstructure prediction, in order to deepen the knowledge about what's the link between chemical composition of an alloy, the die design, the condition of extrusion, like temperature, speeds, and so on, in order to have tailored microstructures, fibrous, recrystallized, fully recrystallized, or to avoid typical defects like peripheral grain coarsening or abnormal grain growth. That's something that still today in 2024 is clear from a theory, but the link with everyday practice is not so settled today. So again, FEM simulation, in our opinion, can help us to find this link, and we are really working a lot on this field. Then in the past, we work on sim weld quality, optimization, charge welds, minimization, and so on. Most of them in cooperation with companies, so directly funded by companies. Most of this content is now in the workshop, is the basic of the workshop, of course, after authorization of the company that we worked with in the past, in order to widespread the knowledge to a wider audience that is changing also day by day, because new people is coming in and other people is retiring and having some relax with grandsons and granddaughters.
Yeah. No, that's a challenge for not only the extrusion industry, but for many manufacturers as well, is just the aging of the workforce. And the next generation's coming in. So this is where you come to learn, about everything having to do with aluminum extrusion. So Lorenzo, thank you very much for your time. Look forward to seeing you at ET, which will start on April 29th. And it's really going to be an exciting week, packed full of all kinds of everything having to do with extrusion. So again, thank you for your time today, and we appreciate you, and we'll see you at ET.
Thank to you, Jason, for inviting me and for this pleasure talk. Sorry for mistaking my English. Maybe it's not my mother tongue, but I hope that everybody understood what was my thoughts. Thank you once more.